We're going to evaluate the integral of sine squared x times cosine squared x dx. And we'll do this in two different ways. The first method relies on two trig identities. Sine squared x equals 1/2 times 1 minus cosine of 2x, and cosine squared x equals 1/2 times 1 plus cosine of 2x. So let's go to the integral and substitute. The integral becomes 1/1/2 times 1 minus cosine 2x times 1/2 1 plus cosine of 2x dx. And this simplifies to, we have 1/4 in front, and 1 minus cosine 2x times 1 plus cosine 2x is 1 minus cosine squared of 2x, and of course that is equal to 1/4 times the integral of sine squared of 2x. Now to go from here, we're going to use this identity again. This time on the left we have sine of squared of 2x, so we'll double that on the right. Let me write that here. Sine squared of 2x is equal to 1/2 times 1 minus double 2x, which is cosine of 4x. So we plug that into the integral. We have 1/4 times the integral of 1/2 times 1 minus cosine of 4x, and this is equal to 1/8 times the integral of 1 minus cosine of 4x. And we can now finish the integral. This is equal to 1/8 x, so 1 divided by 8 x minus the integral of cosine of 4x is 1/4 sine of 4x, so this is minus 1/32 sine of 4x. Now in most cases this is sufficient, but sometimes we want to express our answer in terms of sine x and cosine x. So let's do that here. We're going to need the following trig identity. Sine of 2 times theta is 2 times sine theta cosine theta. So here we have sine of 4x, which we can write as sine of 2 times 2x. So here's our theta. Our theta is 2x. This is equal to 2 times sine of theta, 2 times sine of 2x, times cosine of 2x. So now our answer looks like this: 1/8x minus 1/32 times 2 sine 2x cosine of 2x. And let's simplify this. This will equal to 1/8 x minus 1/16 sine 2x cosine 2x. Now these are still not sine x and cosine x, so we have a little more work to do. We're going to write sine of 2x as 2 sine x cosine x, and there is also an identity for cosine of 2x. That's equal to cosine squared of x minus sine squared of x. So let's substitute, and our answer becomes 1/8 x minus 1/16 sine of 2x is 2 sine x times cosine x, and then cosine of 2x is cosine squared x minus sine squared x. And let's simplify this to get the final answer. And the final answer is 1/8x minus 1/8 sine x cosine x times cosine squared x minus sine squared x, which we can write as 1/8 x minus 1/8 sine x cosine x times cosine squared x is sine x times cosine cubed x, and then minus a minus plus 1/8 sine cubed x times cosine x plus c. So that is a final answer in terms of sine x and cosine x. Now there's another way to evaluate this integral, and that way we'll use what we call a reduction formula. In later videos there'll be 3 reduction formulas that will be derived, but here is a formula for reducing an integral of cosine to the n of x. So we're taking n to be a positive integer. It is equal to 1 divided by n times sine x times cosine to the n minus 1 of x plus n minus 1 divided by n times the integral of cosine to the n minus 2 of x. So the reason it's called a reduction formula is that the integral on the right hand side has a power of cosine that is less than the power of cosine on the left by 2. So let's return to the integral. We have the integral of sine squared x times cosine squared x dx. First we're going to substitute sine square. Instead we'll write 1 minus cosine squared x times cosine squared x dx. And this is equivalent to 2 integrals. 1 times cosine squared, that's integral of cosine squared x. We actually already know how to do that. Minus the integral of cosine squared times cosine squared, cosine to the 4th x dx. So let's take the higher power here, which is cosine to the 4th, and use the reduction formula on that. And the reduction formula, this n here is equal to 4. So this is 1 over n, that's 1 over 4, times sine x cosine to the n minus 1 of x. N minus 1 here is 4 minus 1. So this is cosine cubed of x, plus n minus 1, which is 3, divided by n, which is 4, times the integral of cosine squared x dx. So we've utilized this reduction formula once. And returning to the integral of sine squared x times cosine squared x dx was the integral of cosine squared x minus the integral of cosine to the 4th of x. And we just established that cosine to the 4th, let me write cosine squared here, minus cosine, the integral of cosine to the 4th, which is 1 over 4 sine x cosine cubed x plus 3 over 4 times the integral of cosine squared x dx. Now because this is an integral of cosine squared and this is the integral of cosine squared, we can combine them. So 1 times the integral of cosine squared minus 3 over 4 times the integral of cosine squared is 1 over 4 times the integral of cosine squared x, and then minus 1 over 4 times sine of x times cosine cubed of x. Now we already know the integral of cosine squared x. You can see it in an earlier video, so I'm not going to rederive it here. This is equal to 1/4 times the integral of cosine squared, that's 1/2 x plus 1/2 sine x cosine x, and then minus 1 over 4 sine x times cosine cubed of x. So the final answer here is 1/8 x plus 1 over 8 sine x cosine x, and then minus 1 over 4 times sine x cosine cubed x plus c. So we're able to evaluate this integral using 2 different methods, but you may want to go back and look at the first method. Let me erase this. In the first method, the answer was 1 over 8x minus 1/8 sine x times cosine cubed x plus 1 over 8 sine cubed x times cosine x plus c. So we look at this answer where we derive it using the reduction formula and compare it to the answer below. They don't quite match up. And so we want to establish that these in fact are the same, because when we evaluate an integral, it should be unique up to a constant no matter what method we're using. So when we look at these two answers, first you see that 1/8 x matches with 1/8 x. We can cancel these. And so what we have to show, we must show that the remaining part, we can also throw out the c, that is 1/8 sine x cosine x minus 1/4 sine x cosine cubed x is equal to, and I'll put a question mark here, minus 1/8 sine x cosine cubed x plus 1/8 times sine cubed x cosine x. So we have to do a little bit of some basic trigonometry in order to show that these are in fact the same. So let me start with the left hand side. We'll take 1/8 sine x cosine x, and this minus 1/4 sine x cosine cubed x we'll write as minus 1/8 sine x cosine cubed x minus 1/8 sine x cosine cubed x. So minus 1/8 minus 1/8 is minus 1/4. It's really the same thing. So now then I'll take this second minus 1/8 sine x cosine cubed x and rewrite it. So this is 1/8 sine x cosine x minus 1/8 sine x cosine cubed x minus 1/8 sine x times cosine x, and then times cosine squared x. So it didn't change anything. And this is equal to 1/8 sine x cosine x minus 1/8 sine x cosine cubed x minus 1/8 sine x cosine x, and let's write cosine squared as 1 minus sine squared x. And this becomes 1/8 sine x cosine x minus 1/8 sine x cosine cubed x, and then minus 1/8 sine x cosine x minus a minus plus 1/8 sine cubed x cosine x. As you can see, 1/8 sine x cosine x and minus 1/8 sine x cosine x cancel, and we're left with minus 1/8 sine x cosine cubed x plus 1/8 sine cubed x cosine x, which is exactly what we needed to show. So the two answers are identical. After we do a little bit of basic trigonometry to transform one into the other, they are in fact the same. For more videos, visit www.mathprepvideos.com.